Whether you're building a new home or adding on, framing up the situation, or putting a roof over your head. If you need to rock it, roll it, or just get on with it, Hometime has a video to help you do it right. Transform your small bathroom into a luxurious master bath, or increase your home's value by updating your old kitchen. Keep your drains draining, your switches switching, and your footing firm. Whether you do it yourself or buy it yourself, Hometime's how-to video guides will help you get the results you want. Will make your next project a success. See your local home improvement retailer for the Hometime video that's right for you.
Hi, and welcome to Hometime. I'm Robin Hartle.
And I'm Dean Johnson. We're just getting ready to build a deck here on the back of this house.
We'll take you step by step through the project and give you a good understanding of what it's like to build your own deck. And we'll start with the layout, go to the framing, the decking, the railings, and the stairway.
We'll give you some basic deck building techniques. We'll also give you a few hints on how to avoid problems that do-it-yourselfers typically fall into. Hometime is made possible by Chevy Truck. Who brings you? Chevy full-size pickups. Today's big pickups for professionals and do-it-yourselfers. Chevy S-Series pickups. Today's compact pickups that play as hard as they work. Chevy's Astro all-wheel drive. Today's mid-size van with standard four-wheel anti-lock brakes. Chevy trucks, the most dependable, longest-lasting trucks on the road. The National Hometime PBS series is made possible by the Stanley Works. Since 1843, Stanley's been committed to building quality tools and other products to help you do things right.
This house is less than a year old, but it didn't come with a deck. Like a lot of new houses, we have a sliding glass door that leads out to nowhere and it's just begging for a deck. So we're going to start ours here and extend it just beyond the kitchen window, but we're going to leave a cutout around this bay window to let light into the basement below.
You know, we've got to have about 400 square feet on this deck.
Actually, it's about 350.
Oh, you figured it out?
Yeah.
Oh, okay. Well, anyway, it's a big pile of lumber. Well, one way to determine exactly how much lumber you do need is to take your plant over to your local lumber yard, and they'll do what's called a takeoff. They'll determine exactly how many 2x6s, 2x10s you'll need. They'll put it in a neat little package, and they'll deliver it out to the site. Say, could I borrow those snips from you?
Oh, sure. Here you go.
Thanks.
Now this is pressure-treated lumber, which means that it's been chemically treated to resist insects, fungus, decay, and rot. And that's what gives it its green color. Now, it's most common to use this type of wood in outdoor projects like decks, where wood is naturally exposed to the elements. Now, it's cheaper than the other wood species like all-heart cedar and redwood, which naturally resist rot and decay.
Say, we're going to need some 2x10s for that ledger board.
I think these are it, right?
Wouldn't you know that at the bottom of the pile?
Oh, God,
Huh?
of course they would be.
Yeah,
Well, I
should we
suppose
start?
we better get them moved, huh?
Tell you what, if
Gee.
you jump down that end, we can start.
Okay.
Yeah, I have to get this thing out of here first. Let's do the top
Let's take
one.
this off. Okay.
Okay. The ledger board attaches directly to the house and actually supports the back part of the deck. Now, we install this first because then we can lay out the rest of the deck according to where the ledger board is located. Now, the best thing to do is to cut out the siding down to the sheathing and then attach the ledger board directly to the framing. Now, what's going to make it easy about this house is it has an unfinished basement, so all the framing's exposed. We'll be lag screwing our ledger board to this 2x10 here at the end of these floor joists. It's called the rim joist. I took out some of the insulation here so you can get a little bit better look at it. Now, you should be able to do the same thing with your deck if it's on the same level as your interior floor. If it's a little bit lower, just attach it to the wall studs. Now, we'll be applying our second ledger board over here. It's a little bit higher than the other one. That's because there's a step down between the kitchen and the family room. In fact, we'll match that step down in our deck outside.
The first ledger board will go here. We'll need to remove as much siding as needed to accommodate for that and for the deck boards it'll support. Now, the question is where to cut. Most people want the top of the deck boards to go close to the threshold to make for smooth passage in and out. That puts the top of the deck board here, so we need to cut the siding on a level line from this point to the end of the ledger board and then take out this trim piece. Now, if you're worried about rain washing in, you could put the board in an inch or two below the threshold.
I'll use a level to mark a cutting line up to the end of the ledger board. Now, the ledger board will actually go from this corner board here on my side over to where the bay window angles into the wall on Robin's side. Then we want to measure down 1.5 inches for the deck board, another 9.5 inches for our ledger board, our 2x10 ledger board, 1/4 inch for maneuvering, and that's our bottom mark to cut from. I'm going to cut the siding using a circular saw. Now I've set the blade so it'll only cut 1/2 inch into the siding. We don't have to worry about cutting into the sheathing at the same time. And this is something you want to be real careful about. This is a wood lap siding, which is pretty easy to cut. It's beveled, so I'm moving the bed across the bottom of the piece above. That'll keep the cut fairly level. A circular saw can't make a sharp corner, but I can finish out the cuts with a chisel. And we remove that board.
If you've got aluminum siding, a circular saw can really chew it up. Now, one tip we've learned is to move the saw backwards along the cutting line, and it'll make for a smoother cut. It does take longer, though.
If you have stucco, there are masonry blades available that will fit a circular saw, and they work pretty slick. But if you have a good-sized ledger board, you're probably going to go through a few, so stock up.
Our next step will be cutting the ledger board to size, so we need an exact measurement. We figured 14 feet on our plan, but we're actually using the distance between the corner boards.
On a deck, you need square ends on your rough framing, but dimensional boards are not always cut to perfect 90-degree angles at the factory, and that can throw you off. So it's best to square off and cut the ends yourself to be sure. It's a good idea when you're cutting treated lumber to wear a dust mask to keep the sawdust from getting inside your system. Well, another thing is, you never want to burn the scraps. Instead, you want to throw these away.
We came up with 13, 11, and 5/8 inches, but you have to subtract 1.5 inches for the two 1x12 skirt boards on either side of the ledger board. So that's 13, 10, and 1/8 inches. So we mark it, and we'll square it off, and then we'll cut it.
Now, the board's cut to size, so we can mark it off 16 inches on center. For joist hangers, it works best to treat the starting point as the middle of the joist, although the real joist will be going in this position. 16 inches from there takes us to the middle of the next joist. I go back 3/4 of an inch, half the joist thickness, 15 1/4. I make a mark there to represent the side of the joist closest to the starting point. Now, from there, I can mark every 16 inches. So 31 1/4, 47 1/4, 63 1/4. The last 3 feet of the board will support a small stairway landing, so I'll also mark the actual edge of the deck 3 feet in, and we'll put a pair of joists right here.
I'll use this framing square to mark in the sides of the joist, starting with a rim joist on the end. The tongue of the square is 1.5 inches wide, the same thickness as a 2x joist, so it does go pretty quick. Once that's done, we get a second 2x10 and transfer the ledger board layout to that. We'll use it later to support the ends of the joists that start at the ledger. The layouts have to match exactly.
We're nailing in the joist hangers. We're using nails that are a little bit fatter than most so they don't shear off, and they're a little bit shorter so they don't go all the way through the 2x lumber.
We've got the marks to help line up the hangers, but sometimes the 2x's are a little thicker than they're supposed to be. And it's hard to force them into a 1.5 inch hanger, so it's a good idea to take one side of the hanger and line it up with the line, pound it in, and then take a scrap 2x10 and position it, and then finish the other side.
At the end of our ledger board here, we have 2 joists together. So we have a double joist hanger to attach it to the ledger board. Now, because these 2 joists are right up against the edge, there's no apparent way to attach the flange on this side, but there's a way to deal with it. Oop. Now, you can literally pound the flange into the shape you need. In our case, we're bending it back 90 degrees. The hammer works pretty well on a solid surface.
There you go. Here's the next one.
Okay.
Thanks. Now, this flange will nail in just like the other joist hangers, but the bent end will wrap around the other end of the board, and we'll nail it in right there. We checked with a couple of inspectors, and they both said the bent hangers will still give proper support.
After nailing in the hangers, we pre-drill them for the lag screws. Now that's a 3/8" spade bit that we're using. We need 2 for each end and 1 between each pair of joists along the rest of the board. Now it works better if you zigzag them a little bit as you go. Well, now we can nail the ledger board up to the house. Now it's just a matter of lining up the top of the board with this chalk line we've snapped 1.5 inches below the siding, an area wide enough for the decking that'll go on top here. Okay, how's your end look down there?
Oh, looks pretty good.
Okay, we tagged in a couple of nails here to nail it in position. Okay, I'm gonna nail this thing down here.
All right, go ahead.
Now we're pre-drilling holes for the lag screws, and we're using the holes in the ledger board here already as a guide. Now we don't want to go all the way through, just through the sheathing and partway into the rim joist, just enough to get the lag screw started. Once the drilling's done, we squirt some caulk into each hole before driving the lag screw. This will seal up the hole and keep moisture out. We're using 4-inch lag screws, which we can hammer in as far as we pre-drilled. With 1.5 inch ledger board and 3/4 inch sheathing, we're going about a good inch into the rim joist. They're 3/8 inch in diameter to give us the holding strength we need. With a ratchet, you can really drive the lag screw heads deep into the wood, and that's not so good. So use washers to stop the heads and limit the surface damage.
Let's get this flash 2 minutes of lunch.
Sounds good to me. Say, I don't think I brought enough lag screws up here.
Wait, you want me to get them for you?
Would you mind?
No problem. I'll get it.
Okay.
The flashing is really a critical part in putting on the ledger board. When it's done right, it protects the siding and the ledger board. It's a piece of galvanized metal or aluminum that comes in a Z shape. As a matter of fact, sometimes it's called Z flashing. The way this works is this part slips under the siding, this sits on the ledger board, moisture just rolls off and it can't get to the protected areas.
It's crucial that moisture not get in under the door threshold. You get a leak there, and the moisture will start rotting everything it hits. So we're putting a thick bead of caulk there to seal it up. The flashing will cover that.
Once the caulk's in, we put the flashing back on, running the flange back up under the siding and seating it firmly under the threshold. Then we can put that little piece of siding back in place and hold it there by hammering down the nails in the piece above.
In wetter parts of the country, you may also be required to put a sheet of flashing or some moisture barrier between the ledger board and the house sheathing to keep moisture from seeping in. So be sure to check with your local building department. At Hometime, we're always moving from job site to job site, hauling around a lot of tools and materials. So we need a truck that can handle the workload, like the Chevy S-Series extended cab pickup.
This truck is ideal whether we're hauling materials from this construction site or driving down the highway. Its new step-designed rear bumper and lower step-up height make loading and unloading easier than ever.
This 2-tier loading feature lets us expand our cargo space. We can store tools on the bottom and materials on the top. And with these convenient cargo tie-downs, we can make sure everything stays secure.
No matter what kind of load we carry, this double-walled construction protects the truck inside and outside and keeps it looking new.
This extended cab gives us even more space for extra tools or for bringing along a couple of helpers on the tough jobs.
This Chevy full-size pickup 4x4 is another one of our favorites for do-it-yourself jobs. This truck comes standard with a 4.3-liter V6 engine to give us enough torque and towing capacity to clear a couple of trees from this new home site. Okay, back up a couple of more feet.
Also standard are its rear-wheel anti-lock brakes that give you controlled, smooth stopping. That's the kind of security you should demand from any braking system. Chevy's got it.
Even Even with all the work we put this truck through, it still looks like new. The double-walled cargo box keeps any wear on the inside from showing through on the outside.
And all of Chevy's fleet-side pickup trucks give us the option of two-tier loading. So we have the option of using the box as is or creating a second loading level. Okay, that's good. Whether we're carrying passengers, hauling cargo, or pulling a trailer, this all-wheel drive Chevy Astro passenger van is the perfect vehicle.
With its combination of all-wheel drive and four-wheel anti-lock brakes, this van gives us the control we need, even in the worst weather.
In fact, the Chevy Astro van has the largest towing capacity of any van in its class, and its versatility makes sense for every do-it-yourselfer.
The spacious cargo area is ideal for hauling these shrubs or any other material. And with these available Dutch doors, loading is even more convenient. No matter what size of your project, you'll get the job done with a Chevy truck.
They've been a big part of every Hometime project, and it's easy for us to see why the most dependable, longest-lasting trucks are Chevy trucks. The ledger boards we installed yesterday will actually support half the deck, and the other half of the deck will be supported by 6x6 posts that will sit on top of concrete piers. So what we want to do now is locate the position for the footings for those concrete piers.
That's a lot easier once the ledgers are in place. And now that they're up, we can lay out the perimeter for the main deck structure. Now, we don't have to lay out the full deck. We just need a few strings so that we can line up the centers of the posts, and we can do that right now.
We'll use our ledger boards as starting points for the string layout. If this were a ground level deck, we could just tack the strings at the proper points. But when it's 6 feet in the air like this, it works best to transfer the points down to ground level with a plumb bob and work from there.
Once the plumb bob's steady, I mark the point on the siding. Tap in the nail there and tie on a piece of builder's line. We're using nylon string, which won't stretch out of shape. This one will represent the left side of the deck.
On the right side, we plumb down from the double joist hanger for the rim joist there, and we secure the builder's line to the siding as we did the first one.
We tie the ends of the strings to these batter boards, which we drove in a couple feet beyond the actual length of our deck. That's so they don't get in the way as we do the footings. To keep everything in line, we now need these strings square to the house or as close to a 90-degree angle as we can get.
To get them square, we use what's known as the 3-4-5 method, which is based on geometry, but it's simple. The idea is to measure out 3 feet from the house on the string here, and then 4 feet along the house from the same starting point. Now I measure between the two marks, and for a 90-degree angle, it has to be exactly 5 feet. Robin adjusts the end of the string till it crosses the 5-foot mark, and then ties it onto the batter board. We go through the same steps on the other side to square off the string there.
Okay, we've squared off this side and this one. All we need now is a string running from here to here along the center of these posts. So we take the distance to the outside of the post, 12'6", and subtract half the depth of our 6x6 post, 2 3/4 inches. That leaves 12'3 1/4. So now we just measure that out on each string, mark it, and run the third string over those marks.
After making those measurements, we set up a couple more batter boards so we can lay our third string over the marks and tie it down. After squaring the two sides with the house, this string should be pretty close to square. But to double check, we'll make sure the distance between the strings is the same along the outside edge as it is along the house.
After that, we start marking the exact locations for the center of each post along the string. Our designer calculated the post locations based on the lumber we wanted to use and the strength our deck requires. We're using the minimum number of posts to limit the clutter below the deck, but it does satisfy all the local codes.
Then once a string is marked, we just plumb down from each point and mark the ground to show the center of our posts and footings. Well, now we can go ahead and start taking down the strings and digging our footings. Now we'll leave the batter boards up so we can re-string the strings again when we go to locate the posts.
Now, you can dig footings by hand, but if you've got to dig down more than a couple feet and your soil is full of hard clay, it's going to take a lot of time and energy. Power augers like this one are available at rental centers, but it does take 2 people to operate one of these. Dean?
This is a gas-powered unit, and it bores in pretty quickly, even in hard clay soils. At a certain point, you do have to raise the auger up out of the hole to clear the dirt it's chewed, and that gets kind of heavy. But it's a lot easier and faster than using a manual post hole digger.
In colder climates, you have to dig your footings down past the frost line, the depth that the ground typically freezes. Otherwise, the deck is going to float up and down as the ground freezes and thaws. In our area, we've got to go down at least 42 inches to get below the frost line. If the ground doesn't freeze in your area, you can get by with concrete blocks set right on the ground.
Oh, by the way, always check with your local utilities before digging in your yard. They can tell you if there's any electricity, gas, or water lines running underground. In fact, they'll usually come out and mark them for you so you don't accidentally hit one. Well, we contracted for the ready mix delivery, but not for the masonry labor, so it's our job to get the concrete from the truck over to the hole. And time for this guy is money, so if we keep him waiting too long, there is an extra charge.
Oh,
Okay,
here we
ready?
go. Yeah, just about,
About there?
Yeah, great. Great. Coming in there, nice, right there.
Getting most
There
of them.
are do-it-yourself concrete mixes that just require water and some muscle to stir it up. But for these 6 footings, we'd have been mixing up about 30 wheelbarrows full.
Okay. Now, the cement truck is pretty heavy, so we didn't want it tearing up the grass. So that's why we're going from the curb over to the holes here. And really, everything considered, it isn't that much work. Okay, ready?
Ready. All right, great.
I'm about the right spot there?
Yeah, back a little. Yep, there you go.
So you want to get the next load?
Yeah, I'd like to try
Okay,
it.
give it a shot.
Here. There you go.
Okay, the concrete's poured in all the footings and the tops of the footings are leveled off. Now we want to set these pier blocks on top of the footings before the concrete completely sets up. To do that, of course, we have to put our strings back up.
Remember, this string represents the center of the post. And so we've drawn a line down the middle of the pier block, and we're going to line this pier block up underneath these strings just to get it positioned properly. Sometimes you get a little off center while digging the footing, so the pier block might not land in the exact middle. But that's okay, as long as it's still on the concrete. Once it's lined up, we level off the top as we press it down into the concrete.
The post will sit on these blocks, which raise the bottom of the wood high enough to avoid standing water. One alternative to a pier block would be to pour the top of the footing higher in the ground and slope the edges down to prevent moisture buildup.
Once the pier blocks are all set, we can take the layout strings back down. We won't need those anymore, but we do need to let the footings cure for a while.
All right, well, now that we have all the footings and piers in, we're basically working from the ground up. So we want to get these posts up on the piers and cut to the right height.
We've already positioned the piers just where we want them to support the deck beams and the joists, so that's no longer an issue. The problem is how to transfer the proper height to the posts. We've already got a plan for that.
We want to make sure this post is perfectly plumb.
We've got the ledger board set at the height we want, so we'll use that as the reference point. We took the straightest 2x4 out of the lumber pile, and we'll set that into the joist hanger. This will represent a support joist. We'll push this up to the post, level it right there.
Okay, and it's plumb right there. Okay, so the 2x4 crosses the post at the same height as the joist hanger. So we'll make a mark and cut it right there. Okay, I'll take the post down.
2x4.
Now, we use a square to draw cutting lines from that mark all the way around the post. And we've got a circular saw to make the cuts. After lining up the blade with the line, the square also helps keep the saw in line as I cut.
The size of your post is going to depend on the dimensions of your deck. 4x4 posts are sometimes strong enough to support smaller decks, but lumber span charts or local codes will often require the bulkier 6x6 posts to support larger, elevated decks, especially if inspectors think you might someday convert the deck into a porch and add the weight of walls and a roof.
The saw blade's not quite deep enough to go all the way through a 6x6, even after cutting all 4 sides. But a handsaw finishes cut pretty quickly. All right, now that we have all the posts cut to size, we're going to drill holes for these little pins here to center the posts over the top of the piers. And we'll start by drilling a hole in each one of the piers using a masonry bit. And we'll drill a matching hole in the bottom of each post.
Say, how's it going?
Oh, this hammer drill looks great.
Yeah, looks like it's going pretty quick. Wow. For the post, I use a square to draw diagonal lines from corner to corner. Where they cross marks the center.
And that's where we drill the matching holes for the pins. I'm using a regular wood spade bit here with a piece of tape on the shaft to guide my depth.
Usually, you don't need to secure the post to the piers. In fact, the weight of the finished deck will anchor it pretty firmly. But in many areas, the inspectors will ask you to use these pins to keep the post from sliding off center or being knocked off the pier.
Oh, we have some stakes and braces laid out here to help temporarily support the posts. So we can go ahead and set all these up now. And to get a better stick, we're using the subfloor adhesive. Get a better bond between the pier and our treated lumber. Now we get to see how well our holes line up.
Okay.
Right here.
Right over here.
Now watch out for your fingers.
Okay.
Get those cards.
Right in. There we go. With the post in, we screw on the braces. We need 2 of them at a right angle.
And we just pound in a stake here, secure this side of the brace, and get it plumbed up. How does that look?
My way a little bit? Okay, great.
About there?
Yep.
Okay. And then we just screw it in position. Where's the drill?
I suppose you need that, huh?
Good. Right about now.
Now that's a basic idea for setting the post. Now we'll set this second brace the same way as we did the first and move on to the next post.
Well, for our next step, we'll start by putting up our first beam. Now, we'll be working on this lower deck here right underneath the sliding glass doors. And our beam here will basically be a mirror image of our ledger board with matching joist hangers to support the joists.
The other day, we marked this 2x10 side by side with the ledger board as we laid it out. It'd be pretty close to the exact match. Now we just nail the rest of the joist hangers on and we're ready to go.
Our first beam is pretty good sized, and it's supporting some fairly long joists. So a single 2x10 isn't going to be enough. In fact, our building inspectors want us to place 3 2x10s back to back. And that gets to be pretty massive. Actually, this looks like a pretty good one right here. Now, if you want to decrease the amount of lumber, you can add more posts or decrease the span.
I've marked the top of each post 3 inches in to help line up the first 2x10, which is the one with the joist hangers. That'll leave just enough room for the other 2 2x10s. Got it there?
Okay, yeah.
Great.
Up here.
Okay.
What have you got over there for a measurement?
Okay, let me check. 8.5.
Okay, I'll move it over 1.5 inches, and we can toenail it.
Great.
Get this on the mark.
Okay.
Right there. Okay, if you can hold it, I'll...
Sure.
Okay, you want to get your side?
Sure.
Okay, should we get the rest of those 2x10s up here then?
Well, I was wondering if we should get all the rim joists in first. Double check that for square before we get all the lumber up here.
Okay, all right. So it makes sense. Why don't we measure for this rim joist here?
145. We're using 2 2x10s for this rim joist. The inspectors wanted it doubled to support the middle part of the deck. Okay, got that one in.
Theoretically, they should just slide right in, but sometimes they can be a little stubborn. Yeah, if you can get yours right up there. I'll weasel mine around over here. It does help to keep them level, though. You ready?
Ready.
Bring it off the edge there.
Okay. You going in okay?
Yep.
Good on this side.
Okay, easy does it.
Okay.
A little bit more on your end.
Okay, I'll
There.
have to pound it in.
Hammer that. To secure the rim joist, we first line up the 2x10s and screw them together. Then we nail through the beam into the ends of the rim joist. And we nail in through the joist hangers. Okay, let me get this thing up here. All right, you want to pull that tight there?
Got it.
Okay.
16, 4.5.
All right, so that's what, an inch shorter than the other one. So we split the rim to go half an inch, and we would do that in your direction, right?
Right.
Okay, I'll move my ladder here and help you out.
Okay. Now with the rim joist in place, we've checked for square by measuring diagonally in both directions. Now if they were equal, they'd be square, but they're not. So we're gonna have to adjust them slightly. And we've removed the nails out of the beam here so we can move it.
Okay, now to make sure that we're moving the beam into the right spot, I marked the beam where it passed over the top of the post, mark a ½ inch over, and then we move the beam into that position.
Okay, you tell me when.
A little bit more,
There,
right
how's-
there. Perfect,
okay.
perfect. Hey, Robin, can you grab this end? All right, now that everything's square, we're screwing our last couple of 2x10s here into the beam and toe-nailing those into the post. Now, it's important that everything's square. It may not seem like a big deal to move the beam a ½ inch over, but if things get cockeyed, your deck boards just aren't going to line up. We're using polymer-coated screws, which will resist rust better than galvanized. These are nice because they're self-tapping, which means they drive into the wood a lot more smoothly.
Now we went ahead and cut all the joists for this section, which are also 2x10. They'll fit into the hangers just like the rim joists.
Because these boards are a little bit longer, they aren't all going to be perfectly straight. They may have a slight bone in what we call a crown. And to pick this out, you just basically look right down the board and try to find it. Now, we'll always install these boards with the crown side up. The weight of the deck over time will tend to straighten them out. So before we install each joist, we check it to see if it has a crown, and then if it does have one, we mark it crown side up. Okay, should we grab this one?
Yeah. The end should be a bit snug. If the joists are too loose, the framing will lose its strength. If it's too tight, you'll throw the beam off pounding it in. Okay, it's in.
All right, well, once we get everything cut, it starts going pretty quick after that, so we'll finish these up tonight. Then we'll start on the upper deck tomorrow. As we finish this first section of our deck, we see the framing for one of the simplest decks you can build, and not a bad starting point for beginners. To summarize, it's a basic 12-foot by 11-foot platform with the joist hung between the ledge board on the right and the beam on the left, which is supported by the 2 posts and footings. The beam overhangs the post on each end by about 9 inches. That's a cantilever system, which is often used to tuck the posts out of sight under the deck. And we'll talk more about that as we finish the project. And the beam is known as a flush beam because its top is flush with the tops of the joists. An alternative is a drop beam, which we'll show you on the second section of the deck.
After finishing the lower section, our next step is setting in the dropped beam that will support the joist for the upper section of the deck. It'll rest on the remaining 3 posts and extend from the end of the first beam we put in to the left side of the deck. That's 17 feet total, which is too long for single boards. So we're splicing shorter ones together over that middle post. With the beam in place, we can then mark off the joist locations. We want those to match the ledger board layout exactly. So we start measuring from the left side as we did on the ledger board. And we carry that layout through all the way to where the beam hits the first section.
This drop beam will support the joist for the upper deck, but unlike the flush beam on the lower deck, this beam will support the joist from below. That's why they call it a drop beam. It's actually dropped below the joist, which rests on top of it. Let's flip this up here.
Okay. We started installing the joists on this side of the deck with the rim joist going in first. We cut the 2x10s here to extend out over the beam by about 1 foot. So this side will be a little longer than the other side. My way just a little bit.
Okay. Okay, I'll push in just a little bit here. All right, and again, to strengthen up the edge of the deck here, we're doubling up our rim joist. And to keep the joist from flopping around, we'll toenail them in as we go.
This is where it gets a little complicated. So let's first check the plan. We framed out this section and this one. Now we want to set a second rim joist here over this one to actually begin the upper level of the deck and support this beam. It starts here where the deck opening angles out to match the bay window. The opening is 2 feet wide, so to locate the exact starting point, we set the tongue of the framing square against the house bay and mark the point where the 2-foot blade touches the rim joist. That's where we want to start the upper rim joist. To get the length of the rim joist, we measure from there to the outside edge of the beam and add in the length of the cantilevered overhang. We cut a 2x8 and a 2x10 to those lengths, and we screw them together with the tops flush. We then use a circular saw to cut one end of the 2x10 at a 30-degree angle. That forms a notch for one end of an angled rim joist we'll put in to match the bay window angle.
Okay.
Okay.
Get the side there.
Ready?
Tip it up. Yep. There we go. Perfect. Are you on your mark there?
Just a little bit your way.
Okay. About like that?
Yep.
Okay, well, this looks pretty good. Now, our 2x8 is sitting right on top of our rim joist, so we have a 7.5-inch step down to our lower deck. Again, just perfect. Our 2x10 is resting on the drop beam.
Now we'll secure this to make sure it stays solid. We'll toenail the 2x8 into the joist below and nail the bottom of the 2x10 into that too.
Okay, I'm gonna nail this in here.
Okay, go ahead. We want to set the beam 2 feet in front of the window, but there's no way to measure it directly. So we first use a string tight against the window to transfer its position to the rim joist. Then we measure out 2 feet and start the beam there. Dean uses the framing square to transfer the 2-foot mark to the top of the upper rim joist. 2 feet.
That should do it. The beam's going to be 3 more 2x10s back to back, and it goes in level with the joist. The ends will be supported by triple joist hangers, which we're nailing into the rim joist. They'll bear a lot of the weight, so later on we'll fully secure the hangers with lag screws.
This one's all set.
All right, if you want to run up the ladder.
Okay. We nailed the joist hangers in on this beam for the joist that'll support the middle part of the deck. We laid it out so it matches the outside beam, and the joist will run straight. This way?
Sideways, yeah.
There we go.
Line up here a little bit.
This is in?
Yep.
Okay.
Down we go.
Okay. Let's come your way.
My way.
There.
In. Once the beam was in place, we went ahead and started putting in the rest of the joists. We cut them all to give us a 2-foot cantilever over the beam.
So did you read the whole paper?
I saved a little bit for the morning break. Well, at any rate, the deck's at the point where most of the difficult stuff's done. We have all the footings dug, all the posts are in, and all the joists are up and installed. So now we can start on some of the finish items. One of the first things we'll be doing is laying out deck boards.
We've chosen pressure-treated 2x6s to cover our deck. The pressure treatment protects wood against moisture and decay, which can really ruin a deck after a couple of years.
Can you help me with this measurement?
Sure.
Well, we're going to start laying the decking here on this lower section right up against the house. Now, you can cut your deck boards so they line up with the outside of the rim. Actually, we're going to let ours run 1.5 inches past. So you figure 1.5 inches on either side. That's a total of 3 inches we'll add to the total length of the board. So our measurement here is 6 feet, 166 3/4, so you figure we'll cut the board to 169 3/4.
We'll also be notching out the ends of this first board to go around the corner boards, 1.5 inches.
Let me mark this up here.
Boy, the wind's really picking up. I'm going to go get my jacket.
Okay, say, would you grab one for me, too?
Yeah.
Thanks.
Took a couple tries, but we finally got the first board cut.
Here you go, Robin.
Great, thanks. So we'll slide it in over the ledger board under the siding. Now, earlier we cut the siding about 1/4 inch higher so it would slip in easier.
You want the board snug up against the flashing, but not too tight. You still want water to be able to run down behind there. Now, it might be real tempting to caulk this area right in here. And actually, if you've done a good job flashing, that isn't necessary. In fact, caulking could actually help to build up water.
Why don't I get that next board cut and measure?
Okay, I'll keep screwing this board in up here then.
How's that? Is that all right?
Pretty good, yeah.
We've set some 3/4 inch plywood down over the joist so we don't have to rely on the ladder so much as we get the deck board started.
As we start to install our second board here, we're going to be spacing it using 16-penny nails. It'll give us about an 1/8 inch gap. Now that's important because if we put these boards right next to each other, they could create situations where water could stand and end up rotting the boards. Okay, I'll get this nail in here. How are you down there on that end, Robin?
Right there, that's
Right
good.
there?
Yep.
Okay, I'll screw that down.
Okay, let's get this through here.
Okay. All right, mine's tight on down
Get
here.
this cord. Boy, this doesn't look so good.
What's that?
The way it hangs over the edge like that. Do you really want to leave it that way until we get all the deck boards on?
Probably would be the safest thing to do, huh?
No, I don't think it's going to. Well, we were going to put all the deck boards in first and then put the stairway on. But the next few deck boards are going to continue over the edge and double as the first stair tread. That means that they'd be hanging over the edge until the stairway was framed.
So I guess we're changing our plans then, huh?
Yeah, I think
I'll start
so.
working on the stairway.
Okay.
Well, it's frustrating. Things don't go a little bit smoother sometimes.
Well, you got to stay flexible.
Oh, yeah. Well, at least we'll get the stairway done this way.
Here we go.
Good. Thanks. We're going to use these 2x12s for our stringers. The stringers are the support boards that the treads rest on top of. Now, our stairway will be just about 9 feet tall, and it'll be 3 feet wide. So the local inspector asked us to use 3 of the stringers on it. Now, we'll go ahead and lay out this first one here. That's where this framing square comes in really handy. Now, our stair height is 104 inches, so we want to lay out 14 treads separated by a 7.5 inch rise. 14 times 7.5 is 105. But with a 10-inch run, our stairs will run a bit past the deck with the ground about an inch lower, so we'll be fine. To lay out the stairs, we'll use our framing square, and we'll work with our 7.5 inch rise and our 10-inch run. So these will actually be the steps. First thing we want to do is lay out the top of the stringer, and we do that by establishing our 10-inch run on this side, our 7.5 inch rise. The top of the string will be 10 inches, so we move the framing square down until the 20-inch mark hits this side of the 2x12. And we reposition everything to make sure it's on the mark, and we draw in that line. We draw a 90-degree angle down from that, and that will establish the back of the stringer.
We also want to notch out the back of the stringer for a 2x4 scab, which will help secure it. So we mark that in too.
Now what we do is just keep moving our way down the line here by marking our 7.5-inch, 7.5-inch rise and 10-inch run, like so. We draw on our first step, and we just continue to do that all the way down the 2x12. And 10. You have to do a little bit of adjustment because you want these to be as correct as possible, especially if you're laying out 3 stringers. You want everything to line up just perfectly.
After laying out the stringer, we use the circular saw to make the first cuts along the marks.
The circular blade can't finish where the riser meets the tread properly, though, so we follow up with a handsaw at each corner.
We want all 3 of the stringers to be identical, so once the first one is cut, we lay that over the other 2x12s and use it as a template to mark them.
After cutting the 2x4 braces to the width of the stairs, we screw them to the stringers in the notches we cut. Now we start at the top, securing it to the outside stringers first. Then we screw it into the middle one, which we center on the 2x4. At the bottom, we screw in another 2x4 brace. Now this one goes across the front of the bottom risers. These braces line up the assembly and hold it together pretty firmly. Once that's in, we use a 2x8 to brace the bottoms of the stringer. We cut this to fit between the outside stringers, and we cut 1.5 inches off the bottom of the middle stringer so it'll rest on the 2x8.
Then we raise the stringers up into position. This goes a lot faster with the stringers already assembled, though it's a little heavy. The tops of the stringers should be level with the top of the rim joists. When they're lined up properly, we drive a couple of nails through the 2x4 into the rim joist to hold it. After checking level, we drive in a half-dozen lag screws into the 2x4 scab to hold it permanently. The base should also be level. If it's not, shims can be driven under the base or the blocks can be set deeper in the sand. Ours is level, but we cut too much of the base off that middle stringer, so we set in a 2x4 block behind the 2x8 to support the back of the base.
Once the stringers are in position, we can install the treads. Now, we're using a pair of 2x6s for each tread, so we first cut those to length. Now, we're cutting them a bit long to hang over the edges by 3/8 of an inch on each side. Then we screw those into the stringers. The first 2x6 goes tight against the riser. We space the second board with 16-penny nails, and we screw that in. Using 2 2x6 boards over a 10-inch run is common on deck stairs, and it gives us about 1.25 inch long overhang in front. We have all the treads on now, well, everything except the top one here. And if you'll recall, our treads here are actually a couple of boards here that run across our lower section of decking. So once we get these in place, just a second, I have to get my nails in.
Okay.
Once we get these in place, then we can just keep on decking right across the rest of the deck. All right, there we go. Are you tight down there?
Yep, all tight.
Okay, we
ready to screw them in?
Yeah.
Okay. After finishing the deck boards over the stairs, we got enough deck boards laid out so that we could get rid of the plywood. And these are 12-footers that will push tightly up against the upper deck rim joists on this side and let them run wild on that side.
What have you got there?
62 1/4. What have you got?
Okay, well, I'm 1/4 inch short, so I'm going to have to tighten up my gaps here a little bit. Now, one thing you want to do is make sure that you're keeping your deck boards parallel to the outside of the deck. Now, this isn't real easy to do all the time because sometimes the boards are twisted or sometimes they vary in width, so this isn't something that's going to happen automatically.
And sometimes you just mess up. Deanie, you sure you didn't go offline a little bit?
Oh, now either one of us could have done this one. But anyway, what you want to do is just measure off from either side of the deck and even in the middle if your deck is long enough. And if your measurements are equal, you're fine. If they're off a little bit, then just start making some adjustments as you go.
And it's really important to remember, keep checking along the way so you don't run into a big problem in the end.
Shorten this gap here a little bit. That should do it right there. As we get out toward the edge of the deck here, it gets a little bit tricky. You never know quite what size board you're going to end up with. And of course, the worst thing that could happen is you end up with a tiny little sliver.
Well, you could make a pretty good guess on your plan, but things do change when you actually do it. Chances are you are going to have to cut a board to width.
And you do have a certain amount of leeway at this point. You could take a 2x6, cut that to size, or if a 2x4 is a little bit closer, use that. Or like we did here, a 2x8, we cut an inch off the edge there, and then we'll put the cut side right up against the deck. Let me lift that out there. And we'll put the finish side looking out where you'll see it.
Pretty bold here.
Yeah, let me help you out once. Get this started. Okay, ready?
Yep.
Okay.
Well, the deck boards are secured to the lower level, so we'll wrap things up today by cutting the overhang to the proper measurement, which for us is 1.5 inches. So we took the framing square, transferred that measurement to the top boards, we snapped the chalk line, and now we'll just cut it nice and straight.
Okay, that saw's all set here. I'll make the cut
Okay.
on this end.
One thing we want to do on this upper part of the deck is match the deck board layout to the lower deck. So the gaps between the boards line up above and below the step. It looks better that way. It would be hit or miss starting at the house because of the window opening. So we'll actually lay our first upper board directly above the last 2x6 on the lower deck. We first plumb up from the inside edge of that board with a framing square, and we'll line up this end of the top board with that. We also want the other end in line, and we can do that by first measuring from the mark on this side back to the house, and then marking that same distance off on the other side. That'll give our first board a good start. We snap a chalk line between the marks over the joist to line up that first board.
The main part of our upper section is 17 feet wide, and our longest board doesn't reach the other side, so we're using more than one board to cover this area. For proper support, the end of the board has to land on a joist, and we want it right in the middle to leave enough support for the second board. We're again letting the ends run wild, and we'll cut those off later. We're making our first splice about 12 feet from the step, and there are no rules on where you put the splices, but we'll stagger them so they don't land on the same joist. It helps tighten the joint if you angle the screws for the second board towards the first.
After finishing that first row, we then move forward to cover the front of the deck. We'll be cutting the boards at an angle over the bay later so that we can let those hang over the edge. But that last board is another 2x8 cut down to the width we need over the front edge. After those boards are screwed in, we start working our way back to the house. The main concern is to make sure the splices don't fall into a noticeable pattern, which becomes pretty conspicuous. It's better not to notice any splice pattern at all, and the best way to do that is to lay out the splices at random as we go along. Now, as we progress toward the house, we'll also be checking to make sure the boards are lining up with the ones on the lower deck.
When we get to the opening around the bay windows, we hang the ends of the deck boards over the angled rim joist while maintaining an overall sequence. Later on, we'll cut the ends to match the overhang on the rest of the deck and follow the angle of the rim joist. The angle leaves us a small triangle at the corner, and I cover that with a leftover piece of 2x12. Then we continue back toward the house. we cut the last couple of lengths since we can't get the saw close enough to the house to cut them with the others. And to avoid any problems getting the final board in against the house, we lay that in before the next to the last board and screw it in. Then we put in the next to the last board and screw that down to finish the deck board. Our sequence did go off a little as we had to rip 1.5 inches off this one to fit properly in the remaining space.
Well, you know you're headed into the home stretch once you get all the decking on and you're starting to work on the railing. Of course, that's going to be no small job in itself. We have the whole perimeter here to do, also around the window well. Of course, don't forget the stairway.
Now, the basic railing starts with a post, which is typically attached to the rim joist. The railings go on next, followed by the spindles. And that's generally the same plan we're going to follow, too.
Well, we'll be installing 20 of these posts. We'll be notching out each end like so, and we'll also notch out the decking at each post location, so it's going to be fairly challenging.
Yeah, but that's what makes it fun.
See, well, you get started. Why don't I run over to the bakery real quick?
Oh, no, this is a two-person job. I need you here.
What if I just run that one by you? Okay.
We're using treated 4x4s for our posts. We cut this earlier as a model. We'll cut the deck boards so the notch will fit right over the rim joist, and this tail will hang down. We'll bolt it in to hold it in place. Right now, we'll measure and cut the rest of them. The height of the post determines the overall height of the railing, which should be 36 inches above the deck surface. From that, we first subtract 1.5 inches for the 2x6 cap rail that will run across the top of the post. That takes us back to 34.5, where the notch begins. But for the tail of the post, we add 1.5 inches for the deck board and another 9.5 inches for the 2x10 rim joist. So the notch is 11 inches, and the total post length is 45.5.
We use a circular saw for these cuts, but we do have to cut the 4x4 on two sides because it's too thick to cut on one pass with a saw. That's true as we rip cut the bottom for the notch, which we marked on both sides of the 4x4. To cut the top of the notch, we set the blade to cut at a depth of 1.75 inches, which is half the depth of a 4x4. Then we cut across the 4x4 at the line we marked. These cuts don't quite finish the job. We could use a handsaw, but a hard rap with a hammer usually does the trick. Then we clean out the notch with a chisel, since any wood fragments will throw the post on a plumb.
The posts support the rails and the spindles, and we want to space them close enough to give each railing section enough strength. We also need a post at each corner of the deck and 2 posts in some corners. So with the angled bay in front and the angled opening around the window, it ends up being quite a few.
We'll be cutting the rest of the posts pretty much the same way, so we'll move ahead now to show you how we attach them to the deck. At each position, we want to notch the ends of the deck boards wide enough for the post and flush with the rim joist. To cut the notches out, we're using a saber saw, which cuts with a straight blade in an up and down motion. That lets you turn the blade as you cut, so you can first cut on a curve from the right outside corner of the notch to the left inside corner. You can't do that with a circular saw. After that first cut, you can go back and cut on the lines to finish the notch. If you don't have one of these, you could use a circular saw or a hand saw to cut it on the sides and then use a drill on the back line to make an opening for a keyhole saw. Or you could chip out the notched area with a sharp chisel.
To fully secure the posts, we're spreading construction adhesive on the post, which helps keep them rock steady. On a railing, it's crucial that the post be set in plumb to the front and to the side. That's so the rails end up in straight lines from post to post. Once it's plumb both ways, we drive a couple of screws to hold it there.
To anchor these, we're using 3/8 inch lag screws, so we first have to pre-drill to keep from splitting the post tail. Then we drive the screws through the holes into the rim joist. We're using 2 lag screws on each post to secure them firmly. The lengths of these bolts will vary as we work our way around the deck because our rim joists vary in depth from a single 2x10 to a triple 2x10. That's a general technique we're using for securing our posts. After putting up all the posts on the deck, we're starting the railings. We still have posts to do on the stairs, but they get in the way as we move lumber up, so we'll do those later. We're again using treated lumber with 2x4 top and bottom rails supporting our 2x2 spindles. One way to install this type of railing is to first secure the bottom rail. We're setting it on 4-inch blocks which give us a good height above the deck. And we secure it by screwing the ends at an angle into the posts. We could toenail them, but the hammering might knock the posts off plumb.
After the bottom rail is secure, we do the top rail. Like all the rails, we set it a ½ inch from the front of the posts. That way the backs of the spindles are flush with the backs of the posts. Once it's positioned properly, we can screw it in.
We're finishing the top of the railing with a 2x6 cap rail, which we center over the post so there's 1 inch overhang on each side. We cut my end long with a 45-degree angle to form a miter joint with the cap rail from the adjoining section. And Robin's end goes in flush against the post there. We screw it down into the post and the handrail to secure it. Now remember, we set the handrails flush with the top of our 34.5-inch post, so adding the cap rail gives us a final height of 36 inches, which is standard.
With the cap rail secure, we're ready for the spindles. We cut these to a length of 30.5 inches, which means they go from the bottom of the cap rail to the bottom of the bottom rail. As we cut them to length, we also cut a 45-degree angle on the bottoms to give the spindles more finished look. To secure them, we screw them into the top rail and the bottom rail, and we start in the middle, lining up the bottoms to correct any bowing in the rails. Before setting the rails in, we mark them both for the proper spindle spacing. In our area, 6 inches is the maximum gap between the spindles, but that can vary by region, so be sure to check with your inspectors. Whatever spacing you choose, bear in mind that it looks best if the spindles are spaced equally. To achieve that, divide the length of your rails by the number of spindles and use the result as your spacing.
That gives you the general idea of how we're putting this railing together. There are a couple of steps we're taking to speed things up a little. First, we're using a miter saw to cut the angles on the spindles quickly and accurately. Plus, we've set up a jig at the proper length so we don't have to measure and mark each one individually. Then after cutting the rails to size and marking the spindle layout, we set the rails on the deck and screw the spindles in place. Well, that's easier than trying to install them after the rails are in, as we did on that first section of railing. Now, we're first screwing the spindles into the top rail, making sure they're flush on top.
Once all those are in, we then line up the spindles with the marks on the bottom rail, and we can screw those down. Because of the possible bowing in the rails, we first screw down the middle spindle and then line up and secure the end spindles. Then we can finish screwing off the rest of the spindles. We've got our 4-inch block set against the post to help position the bottom rail. So now we can set the whole assembly in between the posts and screw it in. This does go more quickly than the first method we showed you, so we'll be using this as we continue with the rest of the railing tomorrow.
As on the deck, the first step on the stair railing is installing the posts. We don't need these to line up with the posts on the deck, so we don't have notches in the bottom. And we're notching out the stair tread so the post goes in flush with the stringer. By the way, we temporarily screwed a 2x4 to the bottom of the stringer to help position the post while we plumb it. Then we drive a couple of 4-inch screws to hold it. We'll drive in lag screws to secure it permanently, but first we pre-drill the post for each screw, and we countersink the top of each hole with a 1-inch spade bit, a 1/2 inch deep to bury the screw tops. Then we drive in the lag screws. We left the posts long so we could determine the proper height after installing them. One technique carpenters use for that is to set the short tongue of the framing square over the front of the treads and use a level to transfer the angle from the top of the blade to the side of the post. We transfer that angle to the other side of the post and then cut it along those lines with a circular saw.
For the stairway handrail, we're plumb cutting the ends, which means they'll be plumb to the ground when the rail's installed. We set the adjustable arm on the quick square to the angle of our stairs and marked the cut with the edge designed for plumb cuts. We've chosen lumber that's been cut slightly smaller than a 2x6 with a rounded top and grooved sides for easier gripping. We spread some glue along the side of the post and set the rail in place. The lumber's not long enough to reach the top post, so we've cut this first piece for a miter joint at the center of the middle post. We want the rounded and grooved portion of the rail high enough to keep fingers and knuckles from rubbing on the top of the post. But once it's positioned, we screw it into the post starting at the middle post. And we screw it to the bottom post to secure it. That plumb cut on the ends can also be determined by holding the rail in position and using the edge of the post to mark the cutting line. This treatment's obviously different from the railing on the deck. The 2x6 cap rail is not recommended for the top of the stair railing since you can't grip it. This material works best secured to the inside of the stair posts, and we decided to have it end on the front side of the top post, as you can see here. To make that happen, we had to put the stair posts in without the notches on the bottom. Otherwise, they'd have been too far to one side for this treatment.
We're lining up the bottom rail on this railing to match the top rail, and we're using a 2x4 set over the tread to give us a good spacing. That's where we screw it in. Earlier, we used the angle of the stairs to cut the bottom of the posts. We're also cutting the angle into the spindles for the stair railing along both the tops and the bottoms. Then after marking the spacing for the spindles on the rails, we can screw those in. We cut ours to go in flush with the bottom of the bottom rail and flush with the tops of the posts. To get the spacing, we again divided the rail length by the number of spindles we thought would work best. We marked the layout on the top rail and plumbed down with a level from each mark to mark the bottom.
Well, we're going to finish this railing and then build the railing for the other side of the stairs. While we do that, let's take you back to an earlier Hometime project for a quick look at some deck options you might consider.
I worked on this project with Joanne Liebler, and we used many of the same framing techniques you saw earlier on the tape, although we were able to use 2x8s for most of the joists and rim joists. For the decking, we used a high-grade redwood, and we secured it diagonally across the joist for a different look. We started on one of the diagonal edges of the deck to establish the pattern and marked out from there, using 16-penny nails to space the boards and letting the ends run wild over the end. We used casing nails to secure the boards, driving to every joist they crossed. Nails grip best if they're hammered in at a slight angle, and ring shank nails hold better than plain nails. As we progressed on the deck, we reached a point where single boards couldn't cover the distance, and we had to make splices. The diagonal layout dictated that we miter cut the ends over the joists, so we used a bevel square to mark the cuts. It's easy to split the ends of a deck board if you nail into them. So we pre-drilled first and then nailed the ends down over the joists. Those were the basic techniques we used to finish nailing in all the deck boards.
We cut our deck boards with 1.5 inch overhang, but on this project the boards were cut flush with the rim joist. It's an option that's usually combined with a fascia board that covers both the rim joist and the ends of the deck boards. In this case, we used a 2x10 redwood, which was nailed in flush with the top of the deck boards for a nice finished look. And the 2x10 was wide enough to fully cover the 2x8 rim joist. Installing the railing post is a lot simpler with the deck boards cut flush. The posts can be lag screwed directly to the fascia board as they are here without any notching. That saves time, but it is nice to cut a slight bevel at the bottom as a finishing touch. The spindles are also beveled on the bottom, and they're nailed directly to the fascia board in a much simpler treatment than the one we showed you earlier. These spindles are cut to match the height of the post and lined up below a 2x straight edge as a guide. Once all the spindles are in, the cap rails are nailed over the posts and the spindles.
The stairway for this deck was more complicated because we built a 180-degree turn into it. That meant we had to first build a landing halfway down. Then we ran the stringers from the top of the deck to the landing and from the landing to the ground. These were 12-inch treads, which we covered with a pair of 2x6s sandwiched around the 2x2. Like the deck railing, the stair railing was fairly simple. After setting up the posts, we nailed a 2x6 handrail into the post at a height of 30 inches above the tread. Then we nailed the spindles into the stringer and into the rail to finish it.
Well, the work we've done here and the highlights from some of the other projects we've shown you should give you a pretty good idea of what you'll face when you start building your own deck.
Well, some of it's pretty simple, like on this lower deck here where the corners are square and the framing is straightforward. But you start introducing angles and bays and a step like on this upper deck, and it gets a little bit more complicated.
Whatever the case, good luck on your projects. For Hometime, I'm Robin Hartle.
And I'm Dean Johnson. Thanks for watching. Hometime is made possible by Chevy Truck. Who brings you? Chevy full-size pickups. Today's big pickups for professionals and do-it-yourselfers. Chevy S-Series pickups. Today's compact pickups that play as hard as they work. Chevy's Astro all-wheel drive. Today's mid-size van with standard four-wheel anti-lock brakes. Chevy Trucks, the most dependable, longest-lasting trucks on the road. The National Hometime PBS series is made possible by the Stanley Works. Since 1843, Stanley's been committed to building quality tools and other products to help you do things right.